So I want to talk about numbers and numerals. Okay, now these two concepts are very closely related. And numbers are what you may think of first, which is just an abstract concept: 1, 2, 3, 4. That let us count, right? So these are abstractions because I can have 4 apples, 4 pears, 4 cars, 4 classes, and so on, right? And it's the number 4 is an abstraction that says quantity. Okay, that's the concept that's happening. Now, numerals is just how we write numbers. Okay, and so we can write them using the Arabic numerals, which are the ones that we're familiar with, 0 through 9. We can use just 0 and 1 and use binary or base 2. We can use base 8 where we use the digits 0 through 7, base 16 where we use 0 through 9, and then A, B, C, D, E, F. And we can use other kinds of ways of doing numerals, of writing down numbers that actually have nothing to do with the positional notation that we use for base 10. So let me give you some examples of that, right? Let's take a single number. This is the number 12, okay? It's always the same number because it's an abstraction, it's a concept, 12ness, okay? And what we'll do is we'll write it down in lots of different numerals. So here's the first one. This is the common way of doing it, 1, 2, right? So when we write 1, 2, what we're saying is 1, 10, and 2 ones, okay? And so that's 10 plus 2 is 12. Okay, so yeah, that's the normal way that we use for numbers. Now the Romans wouldn't have done it that way. The Romans would have done XII. So X means 10, okay, and then and I, right? So that's plus 1, and I plus 1, that is 12. Okay, that's the way they wrote numbers down. Actually, they were really handicapped by that. I mean, this should have held them back. And in antiquity, like for example, Plato argued that being able to multiply numbers was kind of the height of it being educated, right? Today, third graders can multiply, and that's because we have a better number system, and I'll explain that a little bit more later. Now here's another way to write down the number 12. This is a different numeral for 12, and what it is the letters T, W, E, L, V, E, which in the natural language English, right, we have agreed that represent that concept 12. Okay. Now here's a different way of doing it, which is more mathematical in nature, and it is base 2. And this little 2 there as a subscript, okay, means that it's base 2. If I put 3 there, then it would be base 3, and so on. And in base 2, I'm counting in 2s, or in powers of 2, as opposed to in tens. So with base 10, we do 1, 10, 100, 1,000. That's what the position means. In base 2, we say 1, 2, 4, 8. So 1, 2, 4, 8, that means that we have 1, 8. Okay, and 1, 4, right? I guess I should use this to make it clear what I have, what I'm using to count and what I'm actually counting. So 1, 8, and 1, 4, and yeah, that's actually 12, right? 8 plus 4. Okay. Here are 3 different ways of doing it. These are computer constants. Okay, and what do I mean by that? You can actually write this in code. Okay, you can say A is equal to 0B 1, 1, 0, 0, okay? And that is exactly the same as saying A is equal to 12, okay? Likewise, you can say B is equal to 0 hex C, which is the same as saying B is equal to 12. You can say C is equal to 0, 1, 4, which is the same as saying C is equal to 12, okay? Notice that it's not the same as saying C is equal to 0, 1, 2, okay? The leading 0 messes everything up. So what's going on here? What's going on here is that many languages, in fact, the languages that are based on C, right? C is a language that came out in the 1970 or thereabouts, developed by Kernighan and Ritchie over in what is now Bell, well, what was Bell Labs at the time, I should say, and what they did was they allowed integers, right, to be written in different bases. So the default is base 10, so you can say x equals 12, and that gives you, well, 1, 2, and that gives you 12. But they also wanted to be able to do things in binary because binary is a common number system when you're doing computers. Okay, so in order to do binary, they said a number has 0b in front of it, like right here. Okay, then the rest of it is simply interpreted to be a binary number. So 1100 in binary is 12. We saw that. So 0b 1100 is just the number 12, right? So that's why that happens. Okay. Now they also liked hex because hex is kind of like binary, except every 4 bits becomes just one hexadecimal digit. And so they had 0x prefix to mean the next number here is in hexadecimal. C is the digit for 12. So here 0xc is simply 12, right? So yeah, that explains that. Okay, and then 014, the computer they were actually working with used 3 bits in words. Actually, have words that were 9 bits long, 3, 3, and 3. So it was actually natural for them to use octal or base 8 instead of base 16. And what they decided was that if you simply put a leading 0 on a number, then that made it base 8 instead of base 10. Sometimes people get confused, like poor freshman programmers, that that's the write a constant, x is equal to 12, and maybe for whatever reason they put a leading 0. Perhaps they're trying to make things align, and it just swaps to base 8, and they have no idea what happened. Now you know exactly what's happening when that goes on. So all of these are different numerals, okay, for the same number. The number is 12. The numerals are so many to choose from, okay. So that's what I want you to remember. That's the key difference between those.